All right, I've already talked or put videos online concerning problems 1, 2, and 3. Now, when you get to problem 4, you run into a different type of problem altogether. The same is true of problem 5. And let me try to explain to you what the difference is. Number 4, you are given 36 centimeters per second. Right, that's a speed. That's a distance unit over a time unit. Speed is distance over time. This is something that's traveling 36 centimeters in distance. That's about yay big every 1 second. And it's best for the purposes of dimensional analysis to flesh out what's written on the paper into this. 36 centimeters over 1 second, 36 centimeters per 1 second. And what you're being asked to do is to convert that to miles per hour. Right? This is not a single dimensional analysis conversion, but rather two. You need to convert a distance unit up top from centimeters to miles. And when you're done with that, you need to convert a time element on bottom from seconds to hours. So there's 2 bits or 2 pieces to this problem. Similarly, in number 5, you have multiple units. Right? In number 5, you have 1.09 grams per milliliter. This is mass over volume. This is a density number. Right? Maybe the density of, I don't know, let's say a certain type of wood maybe has a density of 1.09 grams per every 1 milliliter. Now normally we write it as 1.09 grams per milliliter, but what we really mean is that for every 1 milliliter of volume of the material, we would measure its mass to be 1.09 grams. It's 1.09 grams per every 1 milliliter. Right? And we're being asked to convert that in number 5 to pounds per gallon. This is also a mass or a weight up at the top, and down below is its volume unit. So we have two conversions that we have to consider when doing this problem. We need to do a conversion of mass units from grams to pounds, and then we have to do a conversion on the bottom units of volume from milliliters to gallons. Now, the other 2 problems which were due are 6 and 7. They're pretty straightforward. They're very much like 1, 2, and 3. But let's go ahead and take a look at, say, number 5. Let's do number 5 together here. So it was 1.09 grams per 1 milliliter. All right, now let's get out our conversion factor list, and on the bottom of page 1 there are the exact conversion factors that we need to do the grams to pounds conversion. All right, let's look through this. Let's see. I think there's not just one way to do this. Let's choose let's choose number 1 in the conversion factor list. 1 gram, we are told, is equal to 2.2046 pounds. All right. So we could see that we could get pounds out of this if we could get to kilograms. Now we have grams. Can we get from grams to kilograms so that we could then use this? Well, of course we can. Right? In the metric system, kilo means 1,000. So a single 1 kilogram is equal to 1,000 grams. So these two these two conversion factors right here need to be placed into this equation in order to get the desired effect, if you will. All right, so we are going to include as the first conversion factor the grams to kilograms. Of course, we're going to put grams down here and kilograms up here. The sole purpose of setting these things up in this manner is to be able to cancel out grams. Right. Now, the numbers in question here was 1 kilogram on top and 1,000 grams on the bottom. Okay, so we've used that conversion factor. When we look here, we have kilograms, but we want to get the pounds. So we'll put in kilograms and pounds. Notice kilograms is on bottom, so that kilograms here cancels with kilograms here. And now we could just put in the numbers. 1 kilogram on bottom and 2.2046 pounds on top. 2.2046 pounds goes on top. All right. Now, when you go back and look at problem number 5, we're asked to go from grams to pounds on top, as I explained earlier. And we have pounds on top now. So we're done with the first bit of this, and that is the mass measurement has been converted from grams to pounds. Now we have to go over get after the volume part of it. The milliliters have to be converted to gallons. So let's go back to our conversion factor list, and we're going to look under our volume conversion factors and see if we can't find something that's milliliters to gallons. There's gallons to cubic inches. That's not going to work. Here's 1 US gallon is a certain number of liters, 3.785 liters. Let's write that down. 1 gallon. Let's get rid of this. 1 gallon equals 3.785 liters. All right. So if we could go from milliliters to liters, then we could go liters to gallons, and we'd be done. So now we just have to figure out what's the milliliter to liter ratio. And again, this is just metric system stuff. Milli means 1/1000th of a liter. All right. So if you had 1,000 milliliters, that would be equivalent to having a full liter. So we're going to use these two conversions. One of them we got off of that conversion factor list. The other one, a metric to metric conversion, we get just from knowing the metric system. All right. Now let's put those two into this problem. Let me switch over here to stick blue here. All right. So we go all the way back to the beginning of this problem, and we see that milliliters is on bottom. So we're going to put milliliters on top and liters on bottom. Anything in the bottom cancels with anything on top that's the same. So milliliters on bottom here cancels with milliliters here. And now we just stick in the numbers. 1,000 milliliters to 1 liter. Now our liters need to be changed to gallons. So we're going to go one more here, and liters on top, gallons on bottom. And going back to this first conversion factor right here, 3.785 liters is 1 gallon. Liters cancel. And we're done. All right. What unit up top hasn't canceled? Well, it's right there. It's pounds. What unit downstairs hasn't canceled? Well, it's right here. It's gallons. So I have pounds on top and gallons on bottom, which is exactly what we were asked to do. We were asked to go from grams per milliliter to pounds per gallon. And we've done that. All right. We've done that by assembling this big equation right here. And at each stage, just keeping track of the units. Grams cancel in this one. Kilograms cancel here. Left with pounds, okay? Milliliters then we got rid of. And then we got rid of liters, leaving us with just gallons. All right. So let me pull the equal sign down here, and the units are pounds per gallon. Now, how do I get the number portion here of the answer? I've got the units portion. Well, I go ahead and I can look at this as just numbers. Let me get rid of all of the units here. All right, I'm done with the units in a way. So let's see, what do we have? We have a series of fractions. This fraction multiplied by this fraction, multiplied by this fraction, multiplied by this fraction, multiplied by this fraction. I'm multiplying 1, 2, 3, 4, 5 fractions. When I multiply fractions, I multiply all of the top numbers together. The numerators, 1.09 times 1, which I'm going to skip, times 2.2046 times 1,000 times 3.785. That's everything up top. All right. And now I'm going to multiply all the things down bottom. It's 1 times 1,000 times 1 times 1 times 1, which is just 1,000. Now I want to point something else out to you here. We can simplify this whole thing by recognizing that there's a 1,000 factor up in this part of the problem, and there's a factor of 1,000 underneath it. And what we can do there is cancel it. The 1,000 on bottom cancels with this 1,000 on top, so I'm left with just 3 numbers up top to multiply. And that'll numerically be the answer I need. 1.09 times 2.2046 times 3.785. Let me get out my calculator and do that. 1.09 multiplied by 2.2046 multiplied by 3.785, and numerically I get 9.0954 and a bunch of other numbers, and that's pounds per gallon. Okay, now the last bit of concern we have here is with significant digits. And my rule for significant digits for dimensional analysis will be round your answer to the same number of significant digits as the original given in the problem, which was the 1.09. So how many digits in 1.09? Well, that's 3 sig digs. So I'm going to round my answer to 3. I want the 9, the 0, and the 9, but I have to round off the 5. Now, what's the rule for rounding with the 5? The rule for rounding with the 5 is look at the number in front. If it's odd, round up. If it's even, round down. Well, 9's odd, so I'm going to round this 9 up to a 10. So this is going to be 9.10 pounds per gallon. And that is the answer to number 5.